In this video, we're going to be working through Newton's second law problems with friction. And these are the equations that we'll be using. The first one is the gravitational force, or weight, is equal to mass times g. Acceleration is net force divided by mass. And kinetic friction is equal to the coefficient of friction times the normal force. We're going to start with a box that is being pulled across a horizontal surface. It's going to be pulled to the right. We'll label this FA. It also has a weight. It's on Earth, so there has a weight. We're also going to label the normal force, which will be balancing the gravitational force, and sliding on the surface, so there's also going to be Fk. The mass of the box is 10 kilograms, and the applied force is 60 newtons. And it's accelerating to the right at 2 meters per second squared. And we're going to make right positive and up positive. Okay, so that is the setup of our problem. And our goal here is to find the coefficient of friction. So we want to find out what is mu. What is mu? But to get there, we're going to break this problem up into smaller parts. The first part is going to be finding what the gravitational force is. So Fg equals mg. And so since m is 10, g is 9.8, we have 98 newtons. Okay, so that is the first part, and I can label that here, 98 newtons. And since these two are equal, our second question is going to be, what is the normal force? And so since these are balanced, we know they're balanced because it's not accelerating up or down. This box is getting pulled to the right. So the normal force will also be 98 newtons. The next question we're going to ask ourselves is, what is the net force? And the net force is equal to ma. Since we know that the mass is 10 and the acceleration which is given is 2, that means that the net force is going to be 20 newtons. Okay. Then the next question we're going to look for is, what is the kinetic friction? So we're going to use the net force. Net force, by definition, right, is the sum of the forces. And so to figure out the sum of forces, we're going to take the force. So what forces are horizontally? We have the applied force, and we also have the kinetic friction. And so for the net force, we're going to take whatever force is in the positive direction minus the force in the negative direction. Since right is positive, we're going to take the force to the right minus the force to the left. So force to the right, applied force. Force to the left is the kinetic friction. And we're looking for kinetic friction. So I'm going to move the Fk to the left, move the net to the right. So I end up with Fa minus the net force. The applied force is 60. That was given. So that's going to be 60 minus the net force. We just solved that, which was 20. And we get 40 newtons. So the net force is 40 newtons. Now remember, our goal is to get the coefficient of friction. And now we're going to use our kinetic friction equation. Fk is equal to mu times Fn. Coefficient of friction is mu. And to find mu, it's going to be Fk over Fn. Okay. So Fk, we just calculated that, is 40. Fn, we calculated that up here in part B. That's going to be 98. And we get 0.41. And notice there are no units here because coefficient of friction is a ratio. We're comparing these two forces, so it has no unit. All right, let's take a look at another problem. This time we're going to look for the acceleration. So we have a crate here. The crate has a mass of 15 kilograms. So we can calculate its Fg. We can also figure out its Fn. It has an applied force to the right. Call that Fa. And this Fa is 100 newtons. The coefficient of friction between this crate and the floor is 0.25. There is friction, Fk. All right, and we're pulling this with this force. The first thing we're going to look for is the gravitational force, or the weight. So that is Fg is equal to mg. And since m is 15 and g is 9.8, we get 147 newtons. The normal force and the gravitational force are equal because the object is not accelerating up and down. It's not even moving. So the normal force is 147 newtons. Next, we're going to figure out what the kinetic friction is because we need to find the net force in order to find the acceleration. So we're going to find the kinetic friction. So the kinetic friction is mu times Fn. And mu, coefficient of friction, is 0.25. Normal force, we just calculate that as 147. And we get 36.75 newtons. Okay, so the next step is going to be to solve for the net force. So the net force is the sum of the forces, and we're going to make right positive and up positive. And so we're going to take whatever's in the positive direction minus whatever's in the negative direction. In this case, it's going to be the force to the right minus the force to the left. That's going to be Fa minus Fk. Now, we know that Fa is 100. Fk, we just calculated, is 36.75. And we get 63.25 newtons. So that is the net force. And then lastly, we're looking for the acceleration. The acceleration is the net force divided by the mass. The net force is 63.25. The mass is 15. And we get 4.2 meters per second squared.